Hello, good morning, everyone. Can you hear me? Can one of you verify that? Okay, thanks. Right. So let's start today's session. So in today's session, I'm going to look at another aspect of system design. In this session, we are focusing on how we can design user interfaces. Now, when it comes to systems design, it's a third phase of the 5 phases that we have discussed in the system development life cycle, right? Now, in this phase, we are going to look at the physical design. And that physical design, which meets the specifications that we described in the requirements document. So remember, in the previous stages, we discussed how we can actually gather the requirements. So now, when it comes to system design phase of the life cycle, we have to do 3 things: user interface design, data design, and system architecture. And finally, we will have to come up with what we call system design specification, which is a document which describes all these 3 aspects. Right. So now, when you look at the system design phase, we are going to design a system which is effective, which improves whatever the existing procedures, which is reliable without any breakouts, right? Consistent, available system, and it should also be maintainable. And system is reliable if it is handle input errors, especially when you input. As a humans, we tend to make errors. Make sure that there's no errors when you're making input. For example, you can check whether somebody has correctly entered an email address, right? And any processing errors and hardware failures or human mistakes. So that is what we want to have in a reliable system. Now, maintainable, meaning like it's a flexible, which means, the fixing a problem is a very complex task, and scalable because the demand might change over the time. So the system, we should build in such a way that it could be, expand, or you can go in the other way around, right? And also easily modifiable. And system is effective if you say that it supports business requirement and user needs, right? Okay, right. Now, when you look at successful design, especially when you designed, you have to think like a user, because whenever you design a system, right, you have to think in a user's point of view. That means the user interface should be easy to learn without extra effort. And you have to, see for any problems, issues that you might have to encounter. For example, in the year 2000, early days before 1999, almost all the software, we had 2 digits in the year. And what happened when the year 2000 came? So most of these software breaks down due to this issue. This is known as Y2K issue. So things like that, we should be able to see before it happens. Should provide flexibility. For example, now when you go to ATM machines, usually, you are always directed to money withdrawal because that is what most of the people do. So providing the money withdrawal facility as a default one is a common sense, right? Because that's what you want to do. And sometimes it provides some amounts as well, like 5,000, 10,000, 20,000, and so on. So the default values, so it's flexible, right? You can do it in quick couple of seconds if you want to get money. So that's provides you the flexibility. So you have to think, right? When you're designing a system, it's not just like you blankly design it. You have to provide flexibility as well, right? And manage data effectively. If you see this in the picture, and even in the most of the shops around Kandy, even you might see people with handheld devices automatically reading from the labels. So there are like, they can actually input data automatically. Radio frequency identification devices, or in short, we say RFID, is another technology people use when they need automated input. So in that way, you can simplify whole procedure. Right. Now, having now understanding these successful designs, now let's try to understand what is this user interface. Now, simply, you can say it's a way how users interact with the computer system. In a computer system, we have hardware, we have software, we have screen, menu, functions, the output features. And this is basically affects the two-way communication with the computer and the user. So the interface is the place where it interacts, right? And this is the place where you give the communication, provide the interface for the communication. So that's why it's called user interface. Now, when you're designing user interfaces, you should understand there are some principles. And especially, I told you in the beginning that you have to think in user. You have to see user's point of view. So let's look at what are the user-centered principles of interface designs. First of all, you have to understand the business. So the main thing is, you could be a developer, but when you are assigning a project for a business organization, you have to understand the business thoroughly. Without that, you cannot, provide the good user interface. So understanding the business is the first thing. So good starting point would be to start with the functional composition diagrams, where we have seen all the functional diagrams that we have learned earlier. Second, you should maximize the graphical effectiveness. So this graphics, the usage of graphics is very important. Now, sometimes even without knowing what is happening, by using the interface, user should be able to understand. So that's how sometimes the kids learn better than sometimes the adults, right? Because they understand what is presented in the interface, and giving you different colors, different texture, different way of representing things, you can highlight your features of the user interface. Third, as we discussed earlier, you have to think like the user. Fourth, use models and prototypes, very important. Now, sometimes I have seen when I ask my students working on final year projects, okay, I have built user interface. But when I ask how, they just show me what they have built. It should not be like that. It's like you build a house and show. I mean, no, before that, you have to have your own design. Your story should be there. Like a movie, you know that in movie, you have storyboards. Before you are creating a real movie, you have storyboards where what is happening. Similar to user interface design, we have something called UI storyboards. And this is exactly what we are going to discuss today. So using storyboards, you can present how your user interface looks like. Now, what if your user doesn't like your design? So remember, if you are thinking in terms of your users, and nowadays with all the agile processes, we are pleased to our users. If that is the case, we have to understand their requirements. So we have to first provide them models or prototypes. So one example would be you use user interface storyboards for that. Next, focus on usability. Like I said in the ATM case, you should present most common choice as the default value, like money withdrawal. So it comes as the default mode. I mean, users can choose something else, but that way you can focus on the usability. Next, you always should get users' feedback, because sometimes when you design your user interfaces and some of the items might not have used, either you have to look at the statistics, or maybe the best way would be you can get it from the users itself. Last one, you should document everything. It is because always all the software modules that we develop should be maintainable, and maybe you are working temporary on that. Somebody else has to take over. So documentation is placed to start with, or even the user sometimes has to go through the documentation and understand what is happening. So documentation is very important. Right. Okay. Now here are some components in different look and feel. You know that different operating systems have different look and feel of these objects. So you have text boxes, and then you have autocomplete boxes. You have drop down boxes, check boxes, selections, buttons, list menus, right? So all these different items, and even you have groupings, right? These are some of the components available. And also just pop-up messages like this will educate your user. Same thing in, this is, I guess, in Mac. Same amount of interface, but in how it is rendered in Mac operating system. Yes, text boxes. This is selected text. This is a group. Radio buttons, the push buttons. Right, scroll bars. You have sliders here, pop-up menus. Again, the same set in Android version. You have radio button, context menus. You have buttons, sliders. This is dialog boxes where you get it as a message alert, right? So these are various components of user interface. Another set. So you have seen, like in iOS, usually this is how it look like, especially you have when you have date and time, hours. So you have a separate fixed set of user interface elements. Right, these are readily available, like how to put them up together to create a user-friendly interface is the key issue, right? Okay, now let's try to understand what user storyboards are. Now, in this example, I'm going to show you a very simple application. So in this one, what you see here is the starting point, like this. And then it'll start with this interface. Now you can see it's like a mobile application. So in this mobile application, which shows you a logo and simple label and a text box and a button, right, to type the username. And especially this is to show you the sign-in activity. Don't you have an account? Sign up. For example, if the user comes as the first-time user, then you have to first sign up. In case if you select sign up, you go to the second screen. So you can see when you click up, then there's another arrow which indicates the sign up activity where you can type your username, phone number, and email. You can say sign up. Sign up will direct you to the third interface. So in case if the user is already there, then he will go to the third one anyways. So third interface shows you my profile activity, where we have name, phone number, and email. And there are 3 buttons: my stuff, my birds, and borrow, right? So when you click my stuff, you go to a new window which called my items, where you have several items together, right? And then we have buttons to select, right? And when you say my item activity, and when you click on one of these items you already have, it shows you the details of that item. And if you are adding a new item, right, so you can actually create a name for that. Right. Similarly, if you look at my birds, so here we will have my birds. So we'll show you the same number of items are here. And then we have, sorry, my bits, same items, set of items are here. And when you click it, you will have information here. And when you click on the user, you will get the contact details. When you want to make a bid for the item, you can actually have a bid value, which is you provide a value for that. And when you say borrow, when you search, right, so you can provide with all these details, and when you click an item, it will show you the item details. So you can see, so user interface storyboard means starting from the very beginning, for each action, we had to provide the relevant the screens, what happens in each and every step. So you can use arrows to connect different ones together, so that user will get a complete idea before you really build it, right? So that is the idea of user interfaces. Right. Nowadays, we have devices comes in different shapes. Now, for example, I think you have already done this in your website when you design websites, especially you have to take care of different sizes, different versions for desktop, for a tablet, and also for a mobile. So when you're designing user interface storyboards, you have to think in that terms as well. Now, this is an example where in Sketch, it represents how the desktop website look like. A tablet, in a tablet, how it look like, and how it look like in a mobile phone. Because this is very important before we build, because building will take time. So the idea is you will have a first model or a sketch of how the user interface looks like before you present it to the user. Right. Now let's look at some other example. This is again from the book that I am using. So this is an opening screen of a student registration system. And you can see that it says student services, and there are 6 buttons, right? So when you have a situation like this, usually what will happen, depend on what user need, user has to click one of the buttons, and depending on what user clicks, it should goes to the other screen, following screens, right? Now, some suggestions. So first of all, when you are creating interface, you should aim for easy to learn and use interface. Should enhance user productivity and provide users with help and feedback. Sometimes, for example, if it is not clear, like about the date format, you provide how the date format should be, because we use different date formats, right? Then you should create attractive user layout and design, and use whatever the familiar terms and images. Now, for example, use of even the colors. Now, let's say if you have a red and green, we have something in mind, right? Red means danger, right? In a road, it says stop, right? Green means go. Likewise, we have some common use of these different, colors, the words. So you have to use the same thing. Enhancing the interface is very important. Focus on data entry screens, especially whenever you want to enter user to enter the data, you should make sure that it's limited, right? So auto completion now comes in handy. Next, use validation rules. Whatever user enters, you check whether it's correct. Now, for example, if it is marks, what is the validation rule be? Okay, quick question. Let's say I want the class to answer this, right? Let's say we are expecting user to enter marks. How do I validate whether the user enters correct marks or not? Any ideas? Or how do you validate person's age? Okay, good point. So I got one suggestion from Malinga. Mark should be positive integer values. Good. I think you have solved the problem halfway through. Should be positive. Definitely you can. You have to check whether the whatever entered marks, if it is positive, yes, definitely. If it is negative, it's not invalid. Should be positive. What else? I need more. Good point, Malinga. Anyone else? Definitely your mark should be positive value. Is that all? Same goes with age as well, right? That you have to specify the minimum. What about the maximum? So in other words, you are specifying here that the minimum is 0, right? What about the maximum? Yes, 31 said there must be a limit. Yes, if you know the what is the maximum, let's say if it is 100, you should they say that okay, the value should be between 0 to 100, isn't it? So you should specify that as a validation rule if you know, right? So really it might change to 50 to 200, whatever. But in general case, the marks, if you're assuming that the marks is from 0 to 100, you should specify what is minimum and what is maximum. And what is allowable is in between. Good point. Same goes with age as well. Usually you can put, okay, it should be between 0 to 120, right? Average case actually. So make sure that you do that. Validation is very important. Last one, reduce input volume. Like if you're going to do everything by typing, for example, it takes years to finish sometime. So you have to find ways to limit this, especially bulk inputs. So that's why we have other automated inputs are there. So use them, right, when you're designing user interface. Okay. Now in this one, this is called menu hierarchy. And it shows you how the command function into logical group of sequences. And it's look like the functional decomposition diagrams that we have discussed earlier as well, right? So in customer order tracking system, this is how they have came up with the interface. So when a person goes to main menu, there are 3 options: customers, orders, and products. And under the customer, you have 3 options: add a new user, update a customer data, and delete a customer. Under the orders, you have enter the new order, modify order details, and cancel the order. Under the products, enter a new product, update product data, and delete the product. So I think when you also ask to design the user interface, you should start from here. Usually you start with your functional decomposition diagram. And for each, you have to have an interface, right? Now, this might not very clear to you, but this shows you from main window. This is project management is a main window. And when you click add project record, you will present with another screen. It just show you that when you select from a main window, you will get another window. So this is called switchboard, because when you click this one, you will get another window, right? And in this case, it's a data entry. You enter some data and you can actually save it, or you can access to main menu. So always you start with the main menu, you go to another window, you work on it, you close it, you come back to a main window. Right. And you can see that this is basically, adding some details. Right. I would like to discuss another aspect now, especially when you are designing interfaces. Make sure that most of the data items are filled. That means there are some fields that you can fill. For example, date and time. Isn't it? Now, if it is an invoice, like in this particular case, you can automatically add current date and time, right? And then sometimes, let's say in this particular case, if you just type the customer ID, that means use enter, customer name, if it is existing customer, you can get it from the system. Similarly, item, normally we type the item ID and the description and unit price will come automatically, right? So interface like this, what usually we enter in a custom order, you type the customer ID and you type whatever the item and only the quantities. That's all you need to enter, and everything else will be calculated by the system. For example, here the total value is calculated, the tax is calculated, total price is calculated, and the order number is automatically generated. Simply, entering order means user has to enter three things: custom ID, item ID, and only the quantity. So the idea is you minimize user involvement, right? And you expect very little, so that you are not going to make any errors as well. Right. Now that we have looked at interfaces, the next thing that I would like to discuss is type of reports. Now, the other thing is we have to provide different types of reports for the users. So detailed report is one or more lines of output in each record processed. Exception report, only those records that meet a specific conditions or conditions. That means it meets certain conditions. A summary report, you get total figures. Now let's say if it is a bank account details, when you say detailed report, from starting date to end date, you are going to have everything. Exception report means, let's say you are going to get the report only the deposits, then okay, you focus only on the deposit within the range. And then when you say summary reports, okay, so you will have a summarized report on the dates, on total deposits and withdrawals likewise, right? So we can have different types of reports. Now, when you're designing reports, again, the same principles we have discussed earlier comes into handy. It should be attractive. At the same time, it should be professional as well, because these reports sometimes used to send to the outside and should be easier to read as well. And when you say a good report, you have to have effort and you have to have attention to details. And when you say well-designed report, you analyze, consider the design features. You have to have headers, footers, page headers, footers, column headings, alignment, column spacing, field order, grouping of detail line, everything should be very clear. And your report should be uniform and consistent. When you produce multiple reports, you should share some common design elements. So these are some good practices or design principles. So here is an example of employee hours report with a detailed report of you can see store numbers, employee names, their positions, then different fields, regular hours, overtime hours, total hours. And then you will also see headers. In the header, it says employee hours and then the range. And footer, you have page footer, you have page number. Then under the page header, we have store number, employee name, position, regular hours, overtime hours, and total hours. That is for the page. And report footer, you have grand totals. And then there are some group footers as well. You can see that, right? One, they have store 8 totals, you have some, and store 17 totals, they are separated. So it's well thought about how you actually design the report, right? So well detailed. Right. Technology issues. Most technology advances today affects both input and output and input, because you know that everything has changed. Early days we didn't have touch system. Now we have touch system. Things actually change rapidly. So interface designer, you should also be on alert on these possible opportunities or potential problems of input and output linkage. Right. So let's look at the output technology. We have screen output and printed matter. Output can be in many ways, and system requirement document probably identify using output needs. Right. Now, various output types and technologies. Now we will have, with the chance, we have internet-based information delivery. We can use emails, the blogs, instant messaging, wireless devices, digital audio, image and video, podcast, automated facsimile systems, compute out to micro-com, compute output to digital media, a specialized form of output. These are different types of output types and technologies. And when you look at the input technology, again has changed, right? For example, if I look at the traditional way of keyboard, traditionally we use typing to enter something, we use keyboard, but now body motion detection is also there. But the next emerging, even when you think, it will type, right? Which comes handy with brain-computer interfacing. Right. Now, for example, if you see, if you type in the YouTube BCI wheelchair, you will see that nowadays, without any command, just by thinking, you can control wheelchairs. It's possible. So which means, right? So input technology might change and maybe already there, that when you think, it might type. Right? Similar to goes with the mouse. Then we have advanced voice recognition, where you can just say what you want to do and it accomplish. Pointing devices, microphones, OCR, MICR, graphic input devices, all these now comes as traditional ones. Evolving ones, now we have biological feedback, embedded magnetic data, RFID, where you will see that. So for example, in farmers, you might see yellow tags, where radio frequency identification devices. When you go to grocery stores, sometimes they paste a sticker in the goods that you buy to prevent stealing. So that is RFID. So modern libraries, they have RFIDs. We again a small sticker where the book can be recognized automatically. Right. But the emerging, like we have all these artificial intelligence tools are there nowadays, are coming into the input technology. Right. So things are changing over the years. And this affects the user interface designer's task as well. Right. So when you're designing input methods, you have to think in a couple of terms. First one is it should be cost effective. Although we talk about there are many evolving, some are still very expensive. So you have to compare with the budget, whether it's cost efficient for your organization and the amount of data that you are going to enter. So it should be cost efficient, timely, and it should be simple as possible. Right. So the next one is whether you are going to use a batch input or you are going to have online input. Batch input means like you collect some information and then it's like you work the whole day and at the end of the day, you are going to input everything. And it's called batch input. Online input is like if something happens at the same time, if you are inputting, that is online input. Right? So both the batch input, usually it's performed on a specific time schedule. Like it could be daily, it could be weekly, monthly, or longer. Most activities now preferred online data entry. So because of that, one of the thing is like when you do it online, you can validate at the same time as well. Right? So otherwise, what might happen once you get and then when you check, it might be too late or you cannot verify the input details. Then you have data automation. Most of the time we try to automate. Most of the time we are trying to minimize user involvement. For example, post terminals where the grocery stores, when you present a barcode, almost everything comes from the system. ATMs, again, when you present your ATM card and PIN, then everything else is automated. Employee identity cards, early days, you can just use the employee ID card to enter a door or premises. Even you can use it for attendance system. Imprint barcodes on patient identification bracelets. You know that sometimes when you're hospitalized, you will get a number, patient number. Traditionally in Sri Lanka, we have still, traditional paper-based system, but at some hospitals, they provide you a band with the barcode where that barcode contains everything. Again, data automation, for example, when doctor comes in from his mobile phone, point at your barcode and get the information about the patient. And it's easy, right? And also there are like special readers for what we call portable barcode scanners are there. Right. And use of here also we can talk about the batch or the online decision. But the decision is basically based on our business requirement. The next thing is we have to focus on the security and control issues. Now, security means physical protection of data and reports. Control unauthorized ports, devices that can extract data from the system. Having seen that, I mean, I will normally ask this from you. Have you seen like how Google data centers and what are the security mechanisms they have used? Since we come into security, since there are some people here working on security. Yes, can you tell me like what are the physical protections they are using? In typical, let's say Google Center. Security guys. So let's continue with where we have stopped. So we were discussing about security and control issues under the output control includes physical protection of data and reports and control of unauthorized ports or devices that can extract data from the system. So in security wise, we should not allow anyone to access to our data. And second one is input controls. You have audit trails, which users to exactly know what is input and when, where, for example. Now, for example, you have seen we have collected your attendance, and then this includes sometimes the location details, timing details. So we can check the validity of the inputs, right? We can use encryption, password security, data security, and also we can also use creation of access levels, which means sometimes you will have a limited access to some of the functions, from low-level ones just for data entering. The next level can have entering and editing. Maybe the next level, the top level may have all the access and so on. Right. What are the strategies which help to avoid major problems in design? Now, the first one is modular design approach. And the second one is prototyping. When you say modular design, you create individual component. These are called modules, which connects to higher level programmable processors. Now, in a structured design, where we have traditional system and development, each module means specific process. That means data flow diagrams, which we have seen earlier, right? So each module is a specific particular process in the DFT diagram. If you're using a object-oriented design, object classes are represented by code modules, right? So we will again later on learn all these details, especially when it comes to implementation. Now, module design is especially important in designing large-scale systems because separate teams of analysis and programs can work on different areas. They need to create the result. So when you're developing a system, you might design separate modules separately, and then later on you might combine them. The second one is prototyping. So prototyping used when you need a rapid version of the proposed information system, where you have 3 phases: planning, analysis, and design, which comes down to a system prototype, and that can lead to a implemented system, right? So end of product system prototype is a working model of the information system ready for implementation. It's actually, you can say, a rapid development method. Okay, right. I think we have came to end of theoretical part of the session. So the next one is we are going